Okay, so let's try implementing these functions, and then we'll see the difficulty will not be implementing the function, but rather returning the result due to the asynchronous nature. Okay, so what is the query that we need to execute? All the answers to this question, there will be object of type answers. So what I always suggest is to try first the query separately from the program, so that then you are sure you separate the debugging of the query from the debugging of the program. So for example, in the SQLite extension, we have this query editor that lets you write some queries and test them. And so once the query is finished, you can copy and paste there. So what do we need to do? We need to find all the answers related to a given question. Okay, so we have the ID of the question as a starting point, and find all the answers related to that. The answer table contains a question ID, which is an external reference, so a foreign key of the table. So it's quite easy to say, okay, give me all the answers where the question ID is equal to, I don't know, 1. This is the kind of query that we want to run. And with this extension, we can just click on this button here to execute the query. So it will run, select everything from answer where question ID equal to 1, and this is the result. Sorry if with this zoom level it's difficult to see everything at the same time. Okay? So this is an example of the query that we could run, and from the result of this query, we should create an array of answer objects. So do we have all the information that we need to create an answer object? Okay, the answer object needs the answer ID, which is there, the answer text, which is there, the author ID, which is there, 1, 2, 3, 4, but the answer object also needs an author email that is not in this query. The result of this query, in the answer table, we have no author emails, because the author ID is just an external reference, a foreign key to the user table. So we should retrieve also that information if we want, to avoid making an extra query, just forgetting the email of the user, that we need to build an answer object, but is not in the answer table in the database. So the fields of the database are not aligned with the field in the date and score. So date is here, yeah, and the score is there also. So what we should do is to extend this query by also extracting the email of the user who did the question. Okay, so let's do that. We need to have 2 tables now, answered and user, and then the join condition that answer dot user ID author ID is equal to user.id. And then we need to get all the fields from answer plus user.email. So let's try to run it. And so this query ID, text, author ID, date, score, question ID, email. Okay, so I built a query that actually gets the data that I want. I debugged it. Maybe if I want, I can ditch the question ID column by putting the column that I really need instead of the asterisk, but just details. So it's a query that has one parameter, and the parameter is the question ID, number 1. Okay? So let me transfer, maybe make it like that, on 4 lines, so it's more readable. Let me transfer that to my exercise. So this is the query that I need to run. Let me do it like that, just for readability. Okay? And I need to run that into the database connection. We could open the database here in the method, but probably it's more efficient to just open the database once and for all at the beginning of the program. So we could maybe have a global variable here. So we need to import SQLite from SQLite 3, SQLite.database, the name of the file was qa.sqlite, and we can have the error handling that throws an exception. Of course, we need to see where these exceptions or where the errors, where the message go. For the moment, we only have a very simple program that we run ourselves, but when this will be embedded into a server, we need to build the path by which we return the result, and also the path by which we return the errors, so that they can be caught by the front-end program. But for the moment, we just print something. And so this is the database that's being initialized. And so we can use it for running the query. Of course, the question ID should not be 1, should be a parameter here. So I put a question mark here. And we can run the query. db.all the answers, so db.all of this query. We know that this query has 1 parameter, and the parameter is the question ID. But since this is a method of the question object, of course, it will have access to the ID of the question on which it was called. So it will be a base.id. Okay, inside a method of an object, I can have access to the object properties. And then we have the callback for returning the result. So error rows. And then if error is not null, let's say throw, we are not managing errors right now, but we just throw exceptions or print them out. Else, I'm more focused on the data path right now. As we have rows that contains all the information that we need. Actually, it contains information in the form of an array of objects that match my query. I really need to convert these objects into array objects. So I can say that the result should be an array of answer objects, and so we can build for item in of rows. What we could do is to result.push of what? Of the item of a new, answer, and we populate this new answer. We create an answer object for each row, and for this new answer we can have the fields. So the constructor for answer is down below, ID, text, auto ID. So what is the ID of the answer? It's from the query, so it would be item.id. ID. And what is the second argument? Item.text. What are you playing? Item.text. And then we have item dot the author ID is called author ID, yes. The next one should be the author email, which is called just email in the query, item.email. Then we have the date, which is in the field called date, item.date, but the database will return the date as a string. If I want a date.js object, I should convert it to a date.js object, so I should call the date.js constructor. And of course, I need to import the date.js library at the beginning. So where was I? So let's split into some lines. And after date, we have the score. Okay, so I have the result. I create a new answer object using the information from the query and passing them to the constructor and put this into the result. So at this point, just for debugging, let me see what I got. Let's see the result here. And for testing these methods, I should create at least one object of type question and call the method on that. Maybe it's not a real question from the database because we still don't have the method for reading the question from the database. We just build a stupid one as a test program. So we create a question number 1 as a new question with the ID 1, for example, and anything else as parameters. We know we are not using them, so author ID can be 3, author email whatever, date whatever. We know it's just an object for calling the method. And we can call at this point q1.getAnswers. Okay, so sequentially speaking, this program is composed of, okay, instruction on line 6, definition of object on line 8, question, definition of object answer, and these two instructions in the main. This one will build a question object, and the second will call the method getAnswers, and so we run on the first instance of this object. So let's see if I did many mistakes or not. Yeah, new. Sorry. New answer. No, what's that? So let me, okay, I forgot new here. Okay, then see what else. Const, yeah, defining result here, const. And then what else? Let items or const items. Yeah. Houselock AM. Okay, so it printed 3 or whatever answers that all are linked to the same user. Okay, the date you see that is being now it's been printed as a date.js object, so with all the fields. So in this way, what we have the method that can use the property of the object to customize, let's say, its behavior, customize the query, and then build some result. Okay, now the result is here. How can we transfer the result there? Can we do something like this? Getting the return value of this by issuing some return result here? No. If I put a return result here, let me close what I don't need. If I put a return result here, see, look at where we are. We are in this function. And so this return statement in line 36 will be the return of the callback. It's not the return of the getAnswers method. So I'm not returning to the main statement at the bottom. This return value will be ignored. Will be returned to the all method who called my callback. This callback was called by the implementation of db.all, and it doesn't care what I return. Okay, so if I return something from here, it will be lost. And of course, I cannot. If I want to return something, I could return it from getAnswers, right? Why not? The problem is, sorry. If I add a return statement here in the body of getAnswers, which is not the body of all, so this will be returned to the main. The problem is that this result will be empty, whatever I do, because what we saw before, this return statement will be executed before the query gets a chance to run. So there's no way I can get this value out of this function. Well, there's only one way, if we follow the philosophy of asynchronous callbacks. If the main program wants to have the result to this query, provide me a function that I can call when I have the results. So actually, for getting the results out of an asynchronous function, I should provide a callback that receives as input the same that we are doing with the library, but we can do that on our own. So if we want to, print how many are there here in the main program, I should define a callback function here that will receive the list of answers and will print, I don't know, the number. So whatever processing we need to do with the result of the function can only be done in a callback. And this callback will be called by my method here. So here, instead of console.results, this method will receive a callback. CB stands for callback often. And we build the result, and we pass the result to the callback. We are not transferring the error. Otherwise, we should. If we follow the pattern, this callback would have two parameters, two arguments. One would be an error. So in this case, I would return. I would call not turn on error, but call the callback with the first argument with the error. And in this case, I would return callback null, comma, result. So the first argument will be null, and the second will be the result, if we want to transfer the error. But let's make it simple first. So in this case, once this method is called, it will do all the work. When it has the result, it will call this callback function. This callback function is defined there at the calling point. So I'm telling you, please do something, and when you have the result, call my function because I need to do something more. And let's see if it works. Yeah, we have 3 answers. So the only way of pulling a result out of an asynchronous function is providing a callback function which, in an asynchronous way, will be called with the result as an input. We need to twist our brains, I'm sorry. Okay? And just remember that line 56 will be executed well before the query. So we execute line 56. That schedules the query, and when the query is finished, we'll call our callback up there, and that, on turn, it will call this callback in line 56. So this code will be the last to execute. And this code is not called by me. It's called by the callback of the getAnswers, which, on turn, is called by the db.all method. Okay? So this is the way asynchronous programming has gone for many years in JavaScript. And instead of give me the result, we have to think of I will tell you what to do when you have the result. I'm providing you a function that you can call, and you see that the function is in the caller, is in the part of the code that needs to use the results. The problem is that we have to postpone the usage of the results in a callback. We cannot do that synchronously. And it's not difficult to see that the main program ends here. The main program is made of 4 statements that takes 0 time to execute. That's why I said the call stack will be often empty. Once I execute the main program, the only thing I have defined a bunch of objects, and then I'm waiting for the result of this db.all, which is in another library that does its own SQL stuff. When it empties, when it finishes, then this callback will be pushed on the call stack, and then we'll start executing. If this query takes a long time, the call stack will be empty for a long time, and will be open for JavaScript to execute other code. Okay, I said this was the programming pattern for a long time. Then came promises, which is a way of making this a bit more user-friendly, a bit more. Okay? Sorry. The problem is that the so-called callback hell. Okay, so we have doing something that requires a callback whose results cause another callback, and so on. We are a nesting of callbacks where the code basically is executed in the reverse order to what we are writing in the code. Okay, so it becomes very difficult. We have a very deep nesting, okay, of calls, and it becomes very difficult to keep track of what we are doing. Okay, so our brain can manage so much complexity, especially asynchronous complexity. So it's very easy to get lost. Okay. So in 2017, more or less, the JavaScript designers invented a cleaner way of managing that. So the mechanism is the same, but they created in the library an object called promise that helps us to manage in a more standard way, okay, this behavior. A promise is an object that represents the possible eventual future completion successful completion, or possible eventual future failure of a given asynchronous operation. The idea is that when I want to schedule an asynchronous operation, the method for scheduling this operation will return immediately some object to me. Right now, this method doesn't return anything. getAnswer doesn't return anything. It cannot return anything meaningful. Okay? What we could do is to return a special kind of object that represents the asynchronous operation. Okay, you cannot give me the result right now. Okay, give me something, some object, from which I could retrieve the result later on. And this object is a promise. It's an object that sooner or later will be resolved to a value or to a rejection, to a failure. And an asynchronous function, like the one that method getAnswer, it's an asynchronous function, instead of just waiting for requesting a callback, it will instead return a promise to supply the value at some point in the future. So the promise is the object in which we will register the callback in a standard way. Let's see how it works, because it's simpler to be seen than... So, a promise is an object that you create, a normal object, we can create it with new. Okay? New promise. When you create a promise, it will have one parameter, which is a callback. This callback is something that will be executed asynchronously. So, creating a promise means scheduling, for now, without extra delay, its argument, which is a callback. This callback receives two parameters that traditionally are called resolve and reject. And this code could do anything. Inside this block, we can do whatever we want. We can query the database, we can, what we want. At some point inside the code, we can call the resolve function with some value. So we are resolving the promise with the promised value. With the value that I promised before the value, okay, here it is. I'm fulfilling the promise by providing a value. So this is the mechanism by which the callback will return the value to the caller, by fulfilling the promise. Then we'll see from the caller side how it looks like, okay? Right now it's from the callback side, from the asynchronous code. The asynchronous code just runs inside a promise callback, and the way to pull the value out, whatever the problem that we had before, is calling the function resolve. It's not a return, it's a resolve, but it works conceptually in the same way. Here is the value that I want to return. And then we'll see how the caller will be able to extract that. Or if something goes wrong, I call a reject function, which is the second argument. So this is not a special syntax, it's just the name of the two parameters, but let's always call them resolve and reject by following the convention. And in this case, I'm telling the caller, okay, the operation didn't went well. So I'm returning you some error message or some error object, depending on what I want. Something that should not be interpreted as valid data, but should be interpreted as failure data. Okay, so the callback will do whatever I need to do, and then in its code, sooner or later, it must call resolve or reject. Until it calls resolve or reject, the promise is still in the pending state. It's a promise that is still in the air. So it's a mistake to run the promise code to the end without fulfilling or rejecting it. Because otherwise the caller will still be there and wait for an answer. This is from the promise side. And what on the other side, on the main program side? Okay, imagine we have a function that returns a callback, that returns a promise. So for example, I return a new promise with that done something, okay? So in our case, the getAnswers will return a promise object. Now we're going to do this implementation. And the promise object itself, so the promise callback has two parameters, resolve and reject. But it's an object, and as an object, it has its own methods. The promise object has one method called then, and one method called catch. And these methods receive callbacks that are called with the argument of resolve or with the argument of reject, respectively. So when a promise calls resolve with some value, then the promise object itself calls the callback provided with the then parameter, if it was provided. And the argument of this callback is the result, is the value. So again, we are playing the same game. I have a value inside one asynchronous function, and I have a way of getting that value as a parameter of some callback on the caller side. Okay? But this is done in a standard way. I'm not providing the callback to. The callbacks are defined inside the promise object, and I can have this promise object, store it somewhere, and use it later, and so on. It's just an object. Or if something goes wrong, it means that the code calls reject, then the promise object will call the callback function that I defined with a catch method, if I did. So then and catch are methods defined in the promise object. So then and catch are already defined in the library, in the promise object. What I have to provide are just the callbacks. But they already, you see that they already keep separated the good case and the bad case. So we don't have to do if error is null or something like that. Okay? We have one method if the data is okay, one method if we have some error. Let's see, maybe the example. Just one detail, but we'll come to this later. Normally, the then and catch methods return a promise themselves. So it's easy to chain them. For example, we have one method for getting, this is an example of code for interacting with GitHub, for example. We have get the repository information, which is an asynchronous operation, because it needs to call GitHub and get some data. It returns a promise. On this promise, I register a handler for the good case. That will be called when the data is available, and this data will be the repository information, repo, the argument of the callback. Then, at this point, I can extract as well the issues from this repository. So getIssue will be another asynchronous call. And this asynchronous call, since it's asynchronous, it will return a promise. And this promise will also be returned by the then method itself. So if a callback itself is asynchronous, calls an asynchronous function, the promise coming out of this asynchronous function will also be returned by the then statement. So actually, this then applies to the result of this getIssue. And so it's like we are chaining this getIssue with another then. Once we have the issue, we can get the owner. It will return a promise that resolves to the owner object. And then, when this resolves, we get the owner, we send an email, or whatever. So it enables this kind of chaining. A promise calls a callback that returns another promise that calls another callback, and so on, but there's no nesting here. We have not have many braces nested inside each other. It's just a sequential. We are specifying the sequence of events that will go through unless some of them will fail, And in that case, we will skip to the catch method instead of processing the list. If any of these intermediate promises will fail, we have a catch handler registered on them. So it's a way of handling them in a strange way at the beginning, but much more compact. So if we want to do this transformation to our getAnswers method, how does it transform? So let's go again to the getAnswers. So let's call it getAnswers callback, so that we have a new one. This getAnswers. In this case, I don't need to provide a callback because the promise mechanism will manage it for me. Okay. So sorry, is a function that consists of only one statement, creating and returning a promise. So the synchronous behavior of this function, of this method, is creating and returning a promise. Return, new promise, and the promise only has one argument, the callback. Resolve, reject, do something. Now we can execute the code. In the callback, the code that we're writing now will be scheduled to be executed as soon as possible. And it's the same code that we had before. So all of this, most of this, can be reused. So inside this callback, so we are inside the callback. Okay, so we are inside this callback here of the promise. We have the query, we execute the query. Done. Then, if we have some error, we know how to handle that. If we have some error inside the execution of the body, we should communicate this error by calling reject with some information, maybe the error object that comes out of SQLite. So there's a nice protocol, no, for communicating errors. And then it's up to the caller to decide whether to catch this error, to ignore it, or whatever. And from the result point of view, instead of calling it arbitrary callback that may be defined different ways by different people, we have standardized ways of saying resolve. Resolve the promise by providing this result. Okay? Actually, remember that this resolve is the return statement from the asynchronous world. And from the point of view of the caller, getAnswers returns a promise. For example. And if we want to print the results of, we can just say, okay, with the promise, when the promise is fulfilled, the same as here. Okay, so again, we still have to provide a callback to process the data, but we have standardized the mechanism for doing that. Right now, this console.log that doesn't return any value, and so this statement cannot be changed furthermore, because we are not returning any asynchronous value. If we had to return something, that can be changed furthermore, and or we can add a catch for saying console.log, callback that will execute an error and we print the error message, the error object. So we are registering on the promise. So the promise is created and received immediately, but it doesn't do anything yet. It will run asynchronous, and sooner or later the promise code will resolve or reject, and so it will trigger the execution of this callback or that callback. Sorry, here we have some error argument. I should receive it, of course, if I want to analyze it. So in the case, the argument of the callback is the argument of resolve, and the argument of the catch callback is the argument of reject, of course. Okay, now I define this P object just to be explicit, but normally, most often, we just change it like that. Okay, so quit the get answers, and then we, maybe for readability, we do something like this. And it's also easy to read. Get the answers, then print them. Okay, once we understand that it's all based on callbacks, then we can also read it in sort of synchronous way. Okay? By the way, I've been very lazy here. This would not be my first choice of implementation of the code because I'm creating an array by processing the items of another array. This is a map statement. Okay, so I should probably write something like result is nothing more than rows.map, and for every item of the map substituted with a new answer item. So this would be a normal JavaScript implementation. Transform an unnamed object into a class with a given parameter, instead of creating an empty and then pushing. That's what map is for. And then I resolve this result. So actually, if we count, we are actually 3 statements in total, okay, if we make it more compact. The difficult part is to make in peace with the order in which the operations are executed. Okay. Okay, so we have 3 answers, is still there, is still correct. And with the same philosophy, we could also work with the other methods that are requested in the exercise, for example. For example, we can have we have a suggestion down there to implement the function in a given order. For example, getQuestion is a method for getting the question object, which is actually the same as the current one, but to be defined on another object type which is called question list. Okay, so question list manages the list of questions, and each question manages the list of answers. Okay, each object has a responsibility. So the idea is to add another question list, which is an empty object, but it has the method getQuestion by providing the ID, right? Get question returns a promise that resolves to a question with the given ID. So right now we are thinking in promises already. So this get question is a function that takes an ID and returns a new promise, resolve, reject, with a given body. New promise, sorry, like that. By the way, the main question, this one, the main method, sorry, get question, only contains so we are defining a function whose body is made of just one statement, which is a return statement. So this is one of the cases where we can have the simplified syntax. So instead of writing body return, we can have just the expression to be returned. So it's like that. Okay, this question is a method that gets an ID and returns a new promise where all the work is done inside the promise. Okay? So we don't have to specify the body of the first argument because it contains only one return statement. And then the only body we really have is the body of the promise itself. That will be of the same type as before. So we have something like, in this case, we need to search some information for question, and the information, sorry, that we need in the question object is where is the ID, text, author ID, author email. We have all the same problem for author email here. So we could modify this a bit. Let me play a second in the query editor. Question probably is something like that. Question ID is called ID, not question ID. Question, something like that. And we have all this join to get the user email. So let's see if it works. Okay, this placeholder calls me to provide a parameter for the question mark. Question, I did an hybrid. One. So, one. Ambiguous column name ID, sorry, where question ID. This was the error message. Let me make some space. Okay, question number 1 is there. Okay, so just I debug this statement, so it's always nice to have it clean. And get yeah, const SQL equal to multi-line string. Okay. And then, okay, we do the same. In this case, we have a query that is filtering an ID, which is the primary key. So we only have one result, if any. If the ID is valid, we have one result. If the ID is not valid, we have 0 results. So we can just use db.1, get that only returns one value, one row. The SQL string is this one. The argument is the ID that was provided to me. This argument here, ID, is the argument to be injected into the query. And then we have the callback that we call with once error row, a single row. And then if error is not null, we can resolve the error. You see how we can, reject the error. We see that, by the way, a reject, we are calling that inside this function, body, but reject itself is being defined as the argument of the enclosing function. So we are using closures to pass a result not to my function, but to my father function or mother function, whatever you want to call it. Okay? It's easier. I can see the callbacks that surround me and call them. Otherwise, I should return, resolve with a new, okay, no, I actually have two cases. It may be that I have no results. Okay, so I should also say that if row, so what get return when we have 0 results? Error is null because it's perfectly legal to have 0 results, but the row will be probably null. Okay, so if we don't have any row, I'm not sure whether it's null or undefined. I should check the documentation, but by treating as a Boolean, I solve the problem. If I have no row, I need still to reject a new object with a message that could be no results return, no question found, with ID equal to ID. Otherwise, finally, yeah, I can resolve with the object that I need, which is a new object of type question, and I need to fill all the parameters of the constructor. So ID comes from row.id, the text comes from row.text, the author ID comes from row.author ID. Is it called like that? Yes, author ID. With the capital I. And then we have author email, row.email, and find the date.js of row.date. Day.js. Okay, so that should be it. And so in this case, we can replace this creation of the new question as a fake one by loading the real question number 1. We just need to create a question list object. Question list as a new question list object. And then get the question number 1 by calling q1 dot get ql question list dot get question with ID 1. And now it is asynchronous. So I have the question object where in the then of this method, of this promise. So if I want to call the get answers, I should put it into then. Then I receive the question, and they can call q.getAnswers on that. And then, here I'm doing the chaining. Let's put this away, it's the old version. Question list, get question return for 1. Returns a promise that resolves to the object question with ID 1 by querying the database. Okay, when the project is fulfilled, we take this question object, we could store it somewhere, whatever, but now we just need to call the get answers to get the list of answers for that. That will return a promise with the answers, the one that we were playing before. And this promise is also returned by the then method, so that we can call the second then on the result of the first. So if everything is all right, we still have this message. We have 3 answers. But if we change the question number, now the question number 2, you only have 2 answers. Okay? So that's the kind of code we can write with promises. Remember, the program, when we are executing this statement, the program is long gone, is long finished. The program is finished when we execute line 111, which is just schedules this get question promise. Everything else goes on asynchronously. Yes?
I mean, with the today version of the JavaScript, is still relevant to use promises, or we can just avoid them with using a combination of async and await?
Yes, async and await, which is the next step that we're going to see next time, are just a syntax for replacing then and catch, and they are based on promises. So it's not that we have, so promises are a nicer way of looking at callback, or standardizing callbacks. Async and await are syntactical ways of making it easier to work with promises. But for example, when we're building an asynchronous function, we need to create the promise ourselves. So resolving this part here, resolve and reject, is something that we still need to do by hand, let's say. And the consuming the promises now becomes easier thanks to the await statement, basically. Await and async, we'll see next week, are just a mechanism for implicitly taking the asynchronous callback argument and make it sort of synchronous by hiding this kind of... so it just... mentally is the same thing. Syntactically, of course, it's easier. But under the hood, if you're just consuming a library, you see this await statement is very nice. But if you need to create a value, then you need to work with promises, the promises object. So await is just a way of automating the generation and the return of the promises. So of course we will use that a lot, okay? But I wanted to do the steps just to understand what is happening, just to say, instead of seeing it as just a syntax, okay? Because especially when we have complex stuff, it's better to understand what we are doing. And okay. So in fact, the next step, but it's not for today, is having this easier syntax. I only want to make one final comment, and then I'll leave you go, about the add methods, which are a bit different because we need to, in this case, to give an object and then insert that into the database. And the issue that we need to think about is what are the arguments and what is the object that we are creating. For example, the ID. or the user an email. So for example, that question say, okay, I'm giving you a fully constructed question object and you need to store it into the database. Fine. What are the fields of a question object? So it means that I should create an object myself and a new question, maybe the user inputs on a form, and I give you all the information. So what are the information that we need to provide in the constructor of question? This one, this list. And I have at least two problems here. The first is, how do I know the ID? The ID is something that normally the database will assign as a new auto-increment number to avoid any clashes. I cannot imagine what would be a free number. So first of all, a fully constructed question object is not possible, because when I'm building something from user information, the ID is not there. On the other way, the method for inserting the new information database should extract the ID that has been decided by the database. And we saw the variable this.lastID that can be used to extract that. So this is the first point. Second, ID and email. Of course, they are redundant information. In the database, we saw that email is in a separate table. But for the user interface point of view, IDs are meaningless. I cannot say, okay, this is an answer by ID number by user ID 27. Who is there? I need to have the identity of the person. So that's why in the objects here, we propose to store redundant information. Of course, the email is dependent on the ID. And when we do the queries, we can do a join to extract it. Okay? But now we are entering a new question. And what is the information that we have about the author of this question? Probably there's some person which is logged into the system, and the system already knows the ID of this person. So this ID is some information that we should have, normally. The email, okay, maybe we also have this information, but do we need it? Do I need really to tell you the email of a person when you have the database, the user table? Okay? So when asking the database to create a new question, I think we should provide the text, the author ID, and the date. The ID, we don't know it. It will be the database to tell us. And the email, maybe we know it, but it's useless to give an information that is already there. Especially because if we give it wrong, what should the method do? If I'm giving ID 1 and an email which doesn't correspond to ID number 1, should I ignore it or should I flag an error? Well, it should never happen, of course, but if it happens, what we do? So avoiding putting ourselves in the position of having to handle inconsistent data. So in this case, I would question this fully constructed question object. So some of the fields of the question object should be read-only, come from the database to the application, and not the other way around. Okay? So with this in mind, maybe we can try thinking about the implementation of this method, and next week I will publish my solution. We comment it together. Okay? Okay, so thank you for today.